Hello, everyone, my dear students, programmers, or just anybody who are interested in programming, in particular in object-oriented programming, in Python, very popular programming language, maybe number one in terms of its popularity, number one language nowadays. So, welcome. We continue a short course. It's called Object-Oriented Programming in Python. It's just a few lessons, so please, of course, it's better to watch them from the beginning, one by one. It's very nice if you're not only watching, but you trying the coding I provide. Um, so you can always stop my videos. You can always type whatever you see on your screen. You can always compile it, run it. So be proactive, please. Also, of course, your subscriptions, your comments, your likes are highly appreciated because that's the way YouTube works. Now, the previous lesson was about basically object-oriented design, how to develop, how to reuse existing classes, how to make them more advanced. And probably most obvious approach is called composition. I already have some classes, they work fine, but I want to make something bigger. So I put in my new class instances or objects of the existing classes. So that's very simple and at the same time powerful approach to develop, to extend your class's functionality. You just make instance variables as new objects. And we did a very simple example of composition in the previous lesson. We tried to basically assemble from 6 rectangles a box. Now let's talk about another way to extend existing classes, and we call it inheritance. Maybe it's more a little bit more let's say sophisticated. At the same time, it does have certain advantages if you compare with composition. To make it simple, let's say I have already a document created in Microsoft Word and I want to reuse it somehow in my new documents, new books, new articles. So composition is like basically copy paste. So I take my existing documents and I copy paste it into the body of my new document. I embed basically everything I created into the body of my new document. But inheritance is more like creating new document based on the existing template. So you may know Microsoft Word also has a very powerful technique when you do not copy paste, but you create new document based on the existing document. So that's kind of similar about inheritance. It's kind of similar what inheritance does. Okay, let's be more concrete now. I have a class rectangle. It has, if you remember, three instance variables: width, height, and outline. So we can use outline character later on for drawing or visualizing rectangles. Any rectangle has three methods: grow, shrink, and draw. Let's say I want to create more advanced rectangle, but now it has a fill. So it's going to have not three instance variables, four instance variables with height, outline, and fill. But I don't want to do it from scratch. I don't want to waste my time. Let's say my teammate already created rectangle class. It was tested, it's working fine. So instead of repeating many things my teammate did, I'm trying to reuse his work. So I'm going to inherit rectangle class, and based on it, I'm going to create filled rectangle class. Filled rectangle class going to have the same methods: grow, shrink, and draw. Let's take a look at the coding now. And surprisingly enough, new class is very short. But before we continue, let me show you the parent class. When we use inheritance, we use parent-child terminology. So we may call this class as parent rectangle and this class filled rectangle as a child. So child has more or can do more than the parent. Terminology here is not 100% consistent, and sometimes in different languages we call this class base and another one derived. Sometimes, for example, in Java, we call this class as a super class, and the class you inherit is subclass. For my discussion, I think parent-child is okay. I'm going to stick to parent-child terminology. So child inherits a parent, but it has more than the parent does. So if you want to try the exercise of this lesson, please just type it. And what you see here is my parent class, rectangle. You see static members. You see static method, help. You see constructor. So I'm just scrolling down slowly so everyone can actually practice, can type. So constructor initializes three instance variables, and also it does some validation, some checkup. We have properties in our class. So we have getter and setter for both width and height. Grow and shrink, they quite obvious, those methods. Again, look, in order to make the class behavior safer, we validate before we grow or we shrink. And finally, we did draw method, and I split the task of the drawing into three steps. I did drawing in 3 steps: draw top, draw middle, and draw bottom. You see, inside the class, of course, methods can call other methods. That's absolutely normal. But if you do so, if you call another methods within a method, you must provide self prefix. This is very common mistake. Don't forget about self. Okay, good. Field rectangle. It's very simple. When you inherit, you have to provide the name of the new class, and in the parentheses, you have to provide the parent class name. So that's the child in our terminology, that's the parent. And the first thing you have to do whenever you inherit, you have to call the parent constructor. So it's not possible to build anything if you haven't yet built the parent object. So you see, in my constructor now, it's not 3 parameters: width, height, and outline. It's 4 parameters. It's width, height, outline, and fill. That's something new. So that's the difference basically between parent and child. And that's the most important line whenever you start your parent constructor. You must first call the base or child. Whenever you start a child constructor, you have to first call the parent constructor using super keyword and providing all the parameters that rectangle needs. Rectangle needs less and only after the parent class is initialized or constructed, you can now initialize extra fields, extra features. Your child, of course, is more advanced. It may have more stuff, more instance variables, more methods. In our case, we just right now have one extra instance variable, fill, and you see in line 7 it is being initialized. That's it. So that's the whole child class. Very simple right now, but we can test it. So what I'm going to do, I'm going to try it. By the way, of course, because I'm reusing something, I have to connect to my field rectangle file the previous file. This is important. You reusing rectangle class with the properties. So that's why this directive is crucial. Let's go to the test. In a test, what I did, I now import new file. I instantiate in line 3 field rectangle. Now you see there are 4 arguments, not 3, 4. And I'm just reusing the methods defined in my parent class as if they are mine. So that's the beauty of the inheritance. You, for free, basically, without any efforts, you can get a lot of stuff and you can still use it without problems. So all the old methods from parent class, they still good, they still working, you can still use them. Let's try to run it. And let's see what happens. And yes, you see the instance was created. The shrink, first it was drawn, then I did shrink, and then I draw it again. Of course, you don't see yet the field because we haven't yet defined any new methods. So what we're using is just old stuff. But no new method is yet defined in our field rectangle class. So yes, it is working. Yes, no problem. However, definitely we need some improvements because right now draw method doesn't show us the fill of the rectangle. So next class, next lesson, we are going to finally discuss polymorphism. So basically it's going to be our last OOP lesson. So please watch it. We are going to finish tomorrow our short object-oriented programming in Python course. And we are going to show how to add new methods to your child class and how to even change existing methods. So that's the beauty of the inheritance. You're not only adding new stuff, you're not only extending existing class. If you don't like something, you may replace it. We call this feature sometimes polymorphism or overriding. But anyway, I'm looking forward to see you tomorrow. We are going to discuss polymorphism. We are going to make our field rectangle class now completed. Thank you for watching. Please don't forget about subscriptions, likes, comments, and I'm looking forward to see you tomorrow. Bye bye, guys.